All right, everyone. It's my great pleasure to introduce the next speaker to you, Michael Oppermann, or Michi for short, who's a PhD student in computer science with Tamara Munsner at the University of British Columbia in beautiful Vancouver, if I may say so. His research focuses on information seeking in large-scale visualization collections and more broadly on data-driven prototyping, which in my humble opinion is a very hot topic. Before he joined UBC, he actually was in Austria. He's Austrian, and he got a master's degree from the University of Vienna. And so that's how we know each other. He's an amazing coder, one of the most amazing coders I've ever known. It seems effortless to him, in my humble opinion. He has done a lot of D3 tutorials throughout his career, and so it was only fitting to ask him to join the Spring School and give you a tour of D3. Thank you so much, Michi, for joining and doing this for us. The floor,
Thanks for the nice introduction. Thanks. Yeah, today I want to give you a brief introduction, 45 minutes or 60 minutes around. It's not a lot of time to kind of learn a lot of the features and the possibilities of D3, but I want to give you a brief overview at least. So D3 is an open source toolkit that's very popular. It helps us to create expressive, interactive, and web-based data visualizations. D3 means data-driven documents. This is one of the core features. It allows us to bind data to DOM elements and then apply data-driven transformations. So this is one of the fundamental concepts. But what does DOM actually mean? You maybe have heard this before. I kind of assume you are already familiar with HTML, CSS, and the basics of JavaScript. If not, I still think you might find this talk interesting, and it at least helps you to get started with D3. Okay, so let's come back to the DOM. DOM stands for Document Object Model. It's an internal representation of the web page. So as you can see here on the screen, it's basically a tree structure that is composed of HTML or XML tags. And it describes the structure and the content of a website. So the browser, when you open the browser or website, it initially generates the DOM tree when it parses the HTML file or the HTML document of a web page. And then later, once the DOM is loaded, we can modify it with a scripting language such as JavaScript. And then the web page that is visible to the user always corresponds to the current DOM. So if we manipulate the DOM tree here, these tags, then the browser will always update the web page accordingly. And now D3 comes in. It helps us to bind data to these DOM elements, to this internal representation that the browser has of a website. And D3 makes these operations really easy and very efficient. So in this case, I have a very simple array with 3 values. Then I have a few div containers in HTML, and I create a very simple bar chart. When we typically use D3, we bind data not to these div containers, to these HTML tags. We use SVG because it's easier to draw and position them instead of these div containers. They are more intended to create a website layout, to lay out elements on a website, for example. So D3 is not a pure visualization library, and you could use it for many different types of web projects. But efficient DOM manipulation, kind of binding data to these DOM elements, is really useful for interactive visualizations. And this is also one of the main reasons why it became so popular. And so many people use it now for visualizations. Then in addition, D3 provides many low-level building blocks. So for example, you can use D3 to create axes, to quickly add zooming or panning to a visualization. It has also pre-made color palettes that are used very often. Then D3 includes many additional tools. I call them utility functions. these functions, they don't generate visual elements for us, but they help us in the process of creating visualizations. So for example, we can use utility function to load data from an external CSV file, or we can use functions to convert text into data objects, or we can apply automatic binning. So for these kind of things, there are typically other libraries, but they're kind of part of the D3 ecosystem, and we can load and use them. So before I go into further details, I want to provide some general context. You might ask yourself, when should I use D3? I heard it's very complicated, has steep learning curve. The DOM manipulation seems very technical and complicated. So I could just use maybe another tool and load a data set and draw a bar chart or a scatter plot. So I think it's very important to kind of look at the level of abstraction. Let's think of a spectrum from low to high, and on the on the left, the lower end of the abstraction, we have low-level graphic libraries such as 3GS. Here we need to draw everything from scratch, but it has a huge advantage. We can customize everything, so we can decide how every pixel on the screen looks like and have a lot of freedom. And then on the right, there are these ready-to-use chart templates that provide a high level of abstraction. For example, Google Charts or Chart.js, they provide predefined templates of common chart types. So for example, bar charts and scatter plots and all these popular visualization types. But the problem is these chart libraries are limited to these templates, and it's very difficult to customize them or change styles or even come up with some new visualization. So, and then in the middle of this spectrum, we have a wide range of tools that provide composable building blocks or visualization grammars, if you've heard this term before. And here in the middle, kind of closer to the lower end, there is D3 at a lower level of abstraction. And then another example in the middle here is Vega Lite, that allows you to create visualizations using a declarative JSON format. It's a bit easier. You have also some freedom to create a bit more, add a bit more customization to a visualization, but has some limitations where D3 allows you more expressivity. So yeah, the level of abstraction roughly corresponds to the effort that is required to create a visualization, but in the opposite direction. So if we have a low level of abstraction, this requires usually high effort. You need to write a lot of lines of code to create a simple bar chart, for example. And it also maps to expressivity. It's a bit of a fuzzy term. In this context, I mean, how much do we want to customize? How unique is your visualization? Do you want to draw a common chart type, or for example, you want to add maybe some custom annotations, or add some interactive filter options, sorting, etc. Then we need to go down on the ladder of abstraction. So coming back to the question, when should I use D3? It really depends on a number of factors. How much, as I just mentioned, how much customization do I really need? Do I want to create a more complex visualization with multiple linked views? Then D3 should probably is at least on my list very high. And what is my experience with JavaScript? What is the underlying technology stack? For example, do I want to integrate the visualization into an existing system? Then I need a bit more flexibility. Also, a very important part is what performance is required. You can render a few thousand elements with D3 and SVG reasonably well, but if you want to draw, for example, a scatter plot with millions of points, you need to use other technologies, for example, WebGL. So in this tutorial, I want to give you a brief overview of D3, and I hope you will get a better sense of how easy or difficult it is to implement a certain visualization and help you get started. So I will first talk about the general setup of a D3 project. Then I will walk you through the creation of a bar chart. I know I just said that D3 might not be my first choice for creating a simple bar chart, but it's a good example to show some fundamental concepts of D3. I will bind data to elements, load an external data set, create scales, and add axes to a visualization. Then I will continue with a high-level overview of a few other D3 tools. And at the end, I will show you how I would approach the creation of a bit more complex visualization, the uptime plot. I will also share the code, so if I don't have enough time to go through it in detail. So version 6 is the latest release of D3, especially between version 3 and 4, there were some major changes. This can be a bit annoying when you look up examples or tutorials online. Yeah, I will today focus on version 6, and most of the examples have been, or the official examples at least, have been changed already to the new version. D3 is basically a collection of small modules. So you can load individual modules depending on your needs and the type of visualization you want to create, or you can use the D3 bundle, which combines all the core features, and that's what a lot of people do. I mentioned already the stack of web technologies. So visualizations, or D3 visualizations, are embedded into an HTML web page. CSS is used to style elements. And then, of course, JavaScript is used to write the actual D3 code. And we draw the visual marks as scalable vector graphics, or SVG for short. Don't worry if you haven't used SVG before, it's a relatively simple concept, and I will go through it in detail. And then when we create a simple HTML website, or even if we use some JavaScript, we can usually just open the file in our web browser, and it works locally. But this is not possible if we want to load external data with D3. For example, if we want to load a CSV file, we would get a security warning in most browsers, and the visualization will not get rendered at all. So to solve this problem, we need to run a local web server. One option is to just do this from the command line when Python is installed with this code here. This should work by default on any MacBook or also Ubuntu. And then another option is to use an IDE. Maybe you are already using it for coding. An example here is WebStorm. You can just run a local web server inside the CDE. And then another example is Observable, which is a computational notebook for JavaScript. Today, I don't really have time to go into the details of Observable. You can check out their website for examples, and they have also tutorials, and it's also very popular in combination with D3. So here you can see an example project structure. I use the D3 bundle from the official website that combines all the core features. And then I will mostly focus on 3 different files. The HTML file, where we embed the D3Vis, and then the main JS with the JavaScript code. And we have an external CSS file with all the styles. This is a simple HTML boilerplate. It looks always relatively similar. We have here at the beginning, in the header, we load the external CSS file that I call styles.css. And then I have 2 script tags where I link to the D3 library, which I don't touch. And then I have the main JS file where I write my small visualization. And then in the middle, we have the HTML body, where we define an empty SVG container. This is kind of I give it also a size, 500 by 300 pixels. And this is our empty canvas that we want to fill now with visual elements. Okay, so let's add SVG elements. So we can do this directly in the HTML file here. So with these kind of HTML tags, I can define a rectangle and a circle. I can define a few attributes for dimensions and the position and the fill color. So this is relatively self-explanatory. Relatively simple, but typically we don't want to just create these elements manually in the HTML. We want to do this programmatically with D3. Oh yeah, a very important point is also the origin for positioning the SVG elements. It starts at the upper left corner, and then we position and scale elements along the X and Y axis. And this is also very important then for D3, when we now add elements programmatically. So as a first step, I load the D3 library, I select the SVG container in my web page, and then I append a new rectangle. And I apply attributes for the size and the fill color. Very similar to the HTML, but now I use kind of this JavaScript code. These functions are chained together with periods. This looks maybe a bit unusual. This is a JavaScript concept that is very useful for D3. It really helps us to simplify the code, and it's much easier to read. We could split this up into different variable, kind of save the result of each function in a new variable, but this would be much more difficult to read. And here, the output of one method is used as the input for the next method if I chain them together. Okay, but similar as before, I don't want to just append manually a few rectangles. I want to bind data to visual elements. So as a first step, I create an array with 3 elements and I call the variable summits. And then I use D3 to select all the rectangles that are inside the SVG, and I want to bind it to the data. So I say select all rectangle, and then I pass data and the variable summits. This is a fundamental concept in D3. It's kind of called D3 selections or data binding. And here at the beginning, when I execute this code, the web page is empty. So if I select all rectangles, it returns 0 elements because there are 0 elements currently on the page. And then the data has 3 elements, 3 different mountains in my array. So there's this mismatch. And then I can use join, which automatically adds, updates, or removes the elements accordingly based on the match between the select all and the data function. And because there are currently no elements on the web page, join will append 3 elements. And similar as before, I can now define a few attributes. I define the fill color and the size of this rectangle. And then on the right, in this little browser window, you can see one blue rectangle, but actually there are 3 elements. I just haven't defined any position, and they are just drawn on top of each other. So I'm introducing here another important concept, anonymous JavaScript functions, because I don't want to just set attributes manually, such as 450. We want to define dynamic attributes. And with an anonymous function, we can access the data points that correspond to each element. So D is now the data point, and when you iterate kind of through the data points, D corresponds, for example, to Everest. And then I can access it or have it kind of a data-driven attribute. As a first step, I don't even use the variable D. I just use the index. And for every element that I append, I shift it 60 pixels down along the y-axis. And then we can see we have 3 different rectangles here. To keep the code organized, we can also assign classes to elements. So here I assign the class bar to each rectangle. And then I can add styles in the CSS file instead of just mixing it with the D3 code. This is very helpful because we want to reuse styles. Usually, we want to split our styles from the JavaScript code. Makes it also easier to maintain the code and easier to read. So we have usually one or multiple of these CSS files where we define all these rules. Data is typically not just a simple hard-coded array, so I will now use a CSV file with 2 columns. Maybe you access an API or a database, etc. It works relatively similar. So as a first step to load the data, we can use the utility function d3.csv. I give it the path to the file, and then I just print the data to the web console. the console or the development tools in general are really useful for debugging D3 visualizations and any type of web project. So if you haven't used them, you should really check them out. These kind of development tools are available in most of the modern browsers. And yeah, I now copy the code from before, the same code snippet here in gray for creating these rectangles inside the d3.csv function. And we can see here, instead of 3 rectangles, I now have 7 rectangles that correspond to my new data set summits, where I have 7 mountains. Very important here, the CSV function, all the function in D3 to load external data are executed asynchronously. So the web page doesn't freeze when we load the data. But that also means we need to move all the code that uses the data inside the then part. So once the data is ready, we can actually draw the data. And otherwise we can do, can execute maybe other functions in parallel that don't need the data. Yeah, we can also create a separate function and call it after the data is loaded to structure our code a bit. We could create a separate class that kind of is responsible for data loading. And from now on, just assume that our data set is already stored in the variable data. And so I'm not repeating all these code snippets again over and over. Okay, so I have now loaded the dataset summits.csv. I have here 7 mountains, and I want to create a simple bar chart that illustrates the elevation of the 7 summits. So the size of the SVG area is 500 by 300 pixels, and I now want to kind of map this domain data into this small space on screen. And for this, we need scales. And more specifically, a linear scale to map the input domain, which is given in meters, to the output range, which is given in pixels. So here you can see the code for initializing a simple linear scale with D3. First, we specify the minimum and maximum of the input domain. It's kind of from 0 to the highest elevation, and then the output range also from 0 to 500 pixels. And then we can call this function and pass a value. For example, we can call the X scale with 8,849 meters, and it will return 500 pixels. So we can use now this function to map our data to pixel values and actually kind of scale and position the values, the elements accordingly. I make another small modification here, because typically we don't want to hard code specific values from a data set, such as the maximum value. We can just look for it automatically. We can use the D3 max function, go through the data set, check the highest elevation, and save it in the variable. So if we update the code later, if we add mountains or if we change something, we don't break the code. And we could even create a reusable bar chart that is kind of independent of a specific data set. So I just copied here the same code snippet from earlier to draw a simple rectangle for each data point. But now instead of giving it a fixed size, I use again this anonymous function with the variable d that corresponds to a data point. And now I have instead of just array values, I have JavaScript objects because we have kind of 2 columns in our CSV file. So I can now access d.elevation to get the elevation of the current mountain, and I can pass it in as an input to the xscale. And then the xscale function automatically returns the width of each rectangle. And as you can see on the right, we have now a very simple bar chart of the 7 different mountains. Then assume we want to be able to update our data set, and maybe not just the elevation changes, but maybe we want to add or remove mountains. So we need to have a more dynamic Y scale to fit everything into our SVG area. So for positioning these bars, we can use the scale band function. And this is a categorical scale in D3. T3 provides many different types of scale functions. You can check out the documentation. It really depends what type of viz you want to create. In most cases, you will probably need a linear scale that I used before, or you use a categorical scale, scale band, or scale point. Then, okay, here, similar as before, we need to define the input domain and the output range. But because we have now a categorical scale, we don't want to define a minimum and maximum input domain. We want to just get kind of all the different categories. And the categories in our case are all the mountain names. So I can use here the function data.map that returns the title of each mountain, and I get an array of all these strings. And the range is similar. I have a minimum maximum for the height of the SVG area. And padding inner is just a value between 0 and 1. Here I can define how much space I actually want between the rectangles. I updated now these two attributes from earlier to also make them dynamic and not just with hard-coded values. Y-scale.bandwidth gives me the height of each of these rectangles. This is always the same for each data point, independent of which mountain it is. And then I use the Y-scale and pass d.title and shift each rectangle along the Y-scale. So before I just moved them 40 pixels down, but now we do this automatically. The bar chart looks very similar to before, but it's now fully dynamic. And if we update the data set, the rectangles will shrink or expand accordingly. So far, the chart is not very meaningful. We need axes to visually indicate the X and the Y scales. But currently, we use all the space inside of the SVG drawing area for these rectangles. So we need to make some space for so that we can add an axis. And in this example, I want to draw an axis on the top and the x-axis on the top and the y-axis on the left. For this, to solve this problem, I would use a group element. SVG group element is invisible, but as the name suggests, it helps us to group or organize SVG elements. And then I can apply transformations. So here I put all the rectangles into one SVG group and I move it slightly to the bottom and to the right. So first, I need to specify the overall size of the SVG container. It's again 500 by 300 pixels. And I define the margins as I've shown on the right here. And then I can, based on the overall size of the container and my margin, I can calculate the size of the inner chart that we use to draw the rectangles and to specify the scales of the bar chart. And then, as mentioned before, I want to group all the rectangles into an SVG group. So I create an empty group and I translated a few pixels down and to the right. Okay, but I've used the weird syntax here again. What about these dollar signs? These are JavaScript template literals. And if you look up examples online, you will see them probably more frequently now because the syntax is more concise. You can use template literals to embed an expression or a variable inside of a JavaScript string. This is just an alternative syntax to the traditional version where you have these string concatenation. Okay, we have now specified the overall SVG area and the inner size. And now, once we have created the scale functions that I've shown before, we created an X scale, a linear scale, and a Y scale, a categorical scale. It's now very easy to generate the axes for them. We can call T3 axis top for the x-axis and T3 axis left for the y-axis. And then this is a bit confusing. Maybe we need to append empty group elements to the SVG, and then we call the axis functions. And after we execute this code, we can already see T3 is drawing for us the axes with the tick marks and the labels and so on. I just copy here the same code snippet as before to draw and position the rectangles. I don't need to change anything. So the axes and the rectangles are completely independent, and I have these kind of different components. Okay, so here you can, this is relatively small, but here you can see all the code together for drawing the chart once the data is loaded. It's about 45 lines of code for drawing a bar chart. It's maybe looks a bit complex if you haven't seen D3 code before, and maybe confusing at the beginning, but the workflow is actually very similar for most D3 visualizations. You define the dimensions and the layout, then set the scales, the axes, and finally we draw the visual marks, rectangles or circles in the scatter plot, etc. So
can I interrupt?
Yeah.
There's a question what the G means within the chart.
Yes, G means group element. Yeah. So here I append, first I select the SVG area, and then I append the G. This is a group element where I kind of group all I want to group all the blue rectangles together. So because, and also the axes, I also need to use a G element. It's also, I append first an empty group, and then I can call the axes. So so D3 creates for us these grid lines and the tick marks, and they all need to be grouped together. So that's why we have these G elements. It's a bit cryptic, unfortunately. Yeah. Okay, so here, yeah, we can see all the code together. Yeah, workflow is relatively similar. When you look up examples online, I will also share web pages. Yeah, it's generally very similar. So I now want to show you a few other useful D3 tools, more on a high level. This visualization by Amelia Wattenberger presents a really nice overview. You can also check out this website I linked here at the bottom, and I will post it later on Discord. It's interactive, and you can click on the different modules, and it will kind of redirect you automatically to the documentation of D3. So even when you create more complex visualizations, you only use a very small subset of these features, typically only from a few modules, because D3 is modular, and there are many, like you can see the geoprojection modules and geographies, and you need them only for very specific visualizations. So I will not go through all the different modules now, but you should really check them out. And depending on the type of visualization you want to create, there are a lot of utility functions and components that are easy to use. So I will now introduce the shape and the layout generators, because I think they are relevant for many types of visualizations. They are part of the D3 shape and D3 hierarchy modules. And I will first start with the shape generator. So far, I've mostly used rectangles. At the beginning, I once created a circle, but we can also add other shapes. For example, straight lines where we specify the coordinates. We also have text labels, for example, to add a chart title or axis titles. And we can just set these attributes relatively easy with D3, as I've shown before. But sometimes we need more complex shapes. So for example, if you want to draw a line chart, the SVG instructions to create the simple line are much more complicated. And as you can see here, this looks really cryptic. We have these complex path instructions. So fortunately, D3 provides a so-called shape generator function to do this more efficiently, and where we can bind it to data. So instead of the HTML, I'm now back in the JavaScript file, and I specify just some data for different objects with X and Y attributes. And then I initialize the D3 line shape generator, where I need to specify how the attributes from the data set map to the X and the Y coordinates. I called it also in the dataset X and Y to kind of get the connection immediately. And then when we append the SVG path, we can call the this shape generator function that I initially as before, and our data set gets converted into these coordinates. So I select the SVG, I append a path. We do this similarly as before. Instead of a rectangle, I just have a path now, which kind of means you have this curve in SVG. And then the attribute D uses the line function, and I pass my array. D3 has many different shape generators. For example, if you want to draw an area chart, you can use D3 area instead of D3 line. If you want to draw a scatter plot with different symbols, you can use D3 symbols to automatically kind of create triangles and stars and so on. In case you want to draw a bar chart, there's also D3 arc that kind of helps you to create these kind of SVG elements. And then I want to briefly introduce another important concept in D3. Here I selected 4 different visualization types that have a more complex layout than maybe a normal bar chart or a scatter plot. There are many other examples. This is just a small subset of 4 quite different visualizations. So you've seen that drawing rectangles with D3 can be, or is relatively straightforward once you have a bit more experience with D3. But imagine you need to create a stacked bar chart. It doesn't sound much more complicated, but you need to calculate the size and the position of each rectangle. And kind of here, you need to position them along the y-axis, and you need to define the size, etc. So this can be quite cumbersome. And D3 provides utility functions to help us in this process. I call them layout generators. They're not really, there's not really a name for it because it's distributed across different modules. But one is, for example, D3 stack. So you cannot really call, because it's a low level abstraction. You cannot just say D3 stack and it will draw a stack bar chart. But these D3 stack helps you to prepare the data. So the layout generator, they don't have direct visual output, but they kind of take our data and transform it into a new data set that is more easy or more convenient to draw. So D3 stack, for example, computes automatically the positions of these rectangles. Where does it start and where does it end? And then I can draw the rectangles similar as before. For different layouts, we have different types of layout generators. They all have different options to customize them. So you need to have a look at the documentation, depending on the type of viz that you want to create. You can see here already, for example, the stream graph is basically a stacked area chart. So it uses also D3 stack, but then we need to combine it with D3 area to draw these curves. Tree map and tidy tree are hierarchical visualizations. So I use the D3 hierarchy first and then used D3 tree map or D3 tree. And yeah, there are many other of these kind of layouts that are really useful and make it a little bit easier to draw these kind of complex visualizations. Okay, at the end, in the remaining time, I want to show you how I approach the creation of a more custom chart, because when you create D3 visualizations, you maybe want to create more, I don't know, unique charts. I want to customize them. I probably don't have enough time to go through the code in detail, but I will share the source code later with you. So I picked the upset plot, this visualization technique for visualizing intersections of multiple sets. The layout is a bit more complicated. It's quite difficult or even impossible to create it with predefined chart templates or with tools such as Tableau or Power BI. So it's a perfect example to do these kind of things with D3. So what are upset plots? I will use sets of Simpsons characters as example data. Here you can see I have 6 different sets, and the set size is shown on the left. So for example, one set is power plant. So all the characters that work in the power plant are in the set power plant. And we can see it's like five characters on this set. And now imagine we're interested in intersections between these sets. people that work in the power plant are male and evil, for example. Or we want to compare them to other sets, and we want to compare the intersection and see how many characters are in each of these intersections. So we can display them now as a second bar chart at the top, where we can quickly get an overview of the different intersections and their size. And we can see some patterns, and we can see if, how many people are in these kind of combinations. When so how do we recreate this visualization now in D3? When I start the process, I would usually prepare some kind of sketch. I first think about all these components of these multi-view visualizations. Here I divide this into kind of four main components. I have the set size chart on the left, and the set names, then the combination matrix, where I want to show kind of the intersection or the combination between different sets. And then at the top, I have a second bar chart with the intersection size. And then I usually think about the scales that I need and the different components. How are they connected? Because I want to reuse my code. I don't want to create 100 different scales, which is very difficult to maintain and implement. So here you can see already the categorical X scale is shared between the bar chart and the combination matrix at the bottom. So I need one categorical scale for this. And similar as before with our bar chart, here I have a column chart. I can use the scale band function. And then we have different sets. Sets are categories or also categorical attributes. So I need I need a second categorical scale for the y-axis. And then I want to show the set and the intersection size. So as bar and column charts, so I will need two linear scales. And similar as before, I just initialize a D3 scale linear, and I get these linear functions for them. And once I created the scales, I can use the axis top and the axis left function to automatically create the axis components. And D3 will automatically determine an appropriate number of tick values and show these text labels. Then I need various types of SVG elements that I will append with D3. The bar charts are based on rectangles. I've done this before. Then I have text labels to show the set names and the axis titles. Then here I have again these G elements or group elements for every combination or intersection in the matrix. This is not strictly necessary, but it helps me also to kind of structure my code a little bit. So instead of setting the X position of each of these circles, I can just do it once for a group, and then I position the group along the X-axis and move all the circles within one group. Kind of. Yeah, and here I have circles as mentioned, and lines are connecting these sets or circles. And then probably the most complicated part of this chart, if I create this in D3, is the overall layout, because we have multiple views and kind of they're aligned in a grid layout. So I always find it useful to divide these kind of visualizations into rows and columns. And then we also need some margins in between, because we don't want to kind of stick everything together. So we need some space in between. And it really helps kind of to lay this out before you start coding and you create this little sketch. Once I have kind of an understanding of the overall layout, I again create all these G elements or group elements, and I can move all the elements that are inside one chart into one of these groups, and then I shift them along the X and the Y coordinates. And so I can flexibly build my multi-view visualization. Another important part that I usually do before I start coding is to think about the data preparation. How should I prepare the data so it's very easy to draw? So first, I divide the data into two main parts, sets and intersections or combinations. So for sets, I want to draw a bar chart with the set size. So I first, I get some kind of maybe JSON array where I have list all my different sets and the set size. So I can just use them, plug them into an X scale, and then it will automatically kind of give me the size of each of these rectangles. And then the second part are the combinations or intersections. Again, each combination has an ID or a name. I just call it ABCD. And this ID is important because I want to create a categorical scale and for the x-axis to lay the rectangles and the circles out along the x-axis. So I create a categorical scale based on these combination IDs. And then I have the set membership. This just basically means if a circle is highlighted or not. I define the set membership. And then values really defines the characters that are in those kind of combinations or intersections. And I can use the length or the number of elements in the values array to draw the intersection size column chart at the top. I have the source code on this web page. Depending on the time, I can maybe go through it, but maybe first I can answer some other questions before, if there are some.
Thank you very much, Nikki, for a lovely talk. I think we're now all D3 experts. I didn't see any additional questions at the Discord chat. But if there's additional questions, please do ask them either at the Q&A or at the Discord.
Otherwise, I can also go through the upset plot first if there are no questions.
I only see applause, so.
Okay.
So apparently some people are typing, but.
Okay, I will maybe quickly go through it. We don't have a lot of time for this, but just to give you a quick overview compared to, so I earlier showed kind of more in detail how the code looks for a simple bar chart, and then I want to compare it a little bit to this a bit more complex visualization where we we have some interactivity. I can hover over this and it shows me the number of characters in each of these intersections. So again, I have a simple index.html file with the a style sheet, styles.css. Then I define some placeholders for the plot and for the tooltip. I hope this is big enough, or maybe soon. And then I have the JavaScript, the D3 file, and my main.js file. Okay, and then I will go to the main.js. Here at the beginning, I load my Simpsons JSON dataset that I just described, kind of the two parts. I can maybe quickly open this here. So I have here the combinations and the sets. Usually, maybe you also need to do this programmatically, but here I prepared this already. And then I can load it, and I call the function create upset plot. And then I have all my code inside the upset plot here. I could also split this up into further functions, but to just have it kind of simpler for this case. Then as a first step, I prepare the data a little bit. I want to define if each of these circles should be highlighted or not. So I define a kind of a Boolean attribute where I check the set membership. And then I also want to find out at the beginning which of these circles should be connected, because I want to draw only one line. If there are, for example, three circles, I want to draw a line from the top circle to the bottom circle. And then, as similar as before, I will not explain all the variables here, but all these variables, they just describe the overall layout, how big is the overall size, how big are the margins in between the chart, all these different views, etc. In the next step, I define the scales that I described. So I have two linear scales, one for the intersection size here, one for the set size. And then I have two categorical scales, an X scale and a Y scale. And then first I kind of create the SVG drawing area, and then I mentioned these G elements or group elements. So every chart gets its own group element, and that translate means I shift it along the X or the Y axis depending on my settings. And so I create this overall layout. And here then I have these different charts. The first one is the combination matrix here. And I draw a circle for each of these sets, and then I check if it's if the point member is true, then I give it a class member, and then I can just in the CSS file say, if the circle has the class member, I want to draw it green. I can give it a radius, and etc. etc. Here I also add a line where I just define the y coordinates, y1 and y2, to connect these circles here. And then I have the set size and the intersection size charts. They work very similar. Just one is a bar chart and one is a column chart. So I kind of have to be very careful how I use my attributes. And then maybe one thing that I will quickly mention here. So we can also use kind of click listeners or mouse over listeners in D3. I have this here. So I can detect when someone hovers over one rectangle, as I do here. So at the beginning, when you hover over it, I select the tooltip and I say I want to show it opacity 1. And I want to show all the values inside, so all the number of characters. And then on mouse move, I want to update the position of the tooltip. So the tooltip moves with my mouse cursor, which is a bit, yeah, it's nice if it moves instead of just having a static tooltip somewhere in one corner of the screen. And then on mouse out, I just set the opacity again to 0, so the tooltip is hidden in the background. And we could do this with all the different SVG elements. So these click listeners, I can just with dot on, mouse over, etc., or click, I can add various interactive mechanisms to a chart. And then I also need to define axis titles. This is also, I do this just manually. I append a text label and I set a few attributes and the X and the Y position. Okay, I think I will stop here. If there are any questions, happy to answer, but otherwise I can also later answer them in Discord.
Yes, in the meantime, there's a bunch of interesting questions. So what is your experience with the combination of D3 GS and modern GS frameworks such as Vue.js and React? Is that something you would recommend or something to definitely avoid?
No, I think it's becomes more popular. I don't have a lot of experience with React, but I've used Svelte a lot recently. Svelte works similar. It's like a combination between Vue and React. You just have to be very careful when you start your implementation, because these modern GS frameworks such as Vue and React, they want to take care of the DOM manipulation. So they want to kind of have the internal representation of the DOM that I explained at the beginning of my talk. And D3 also wants to manipulate the DOM. So these are kind of interfering. And I find it useful with these modern frameworks to just use D3 as a utility functions. So for example, to create scales, to get color palettes, to get various types of things, but I don't use it to generate visual elements. So I use it only in the background to help me prepare the data so it's easier to draw. But I actually draw the visual elements then with React or with Svelte or all these frameworks.
All right, thank you. And is the tooltip provided by the browser, or did you code it yourself?
I coded it myself. That's also yeah. So I created here an empty placeholder in the HTML. I called it div, and I gave it an ID tooltip, and it's empty. And then in JavaScript, when you hover over one of these rectangles, I fill the tooltips with text and I position it. There's not really an option to do this. There's, for example, a D3 tooltip library that makes this process a little bit easier, but yeah, I think these kind of 8 lines of code or so, it's not so, but yeah, you can copy it between projects. It always works the same.
And just for the record, the Svelte question came from Deepak Purushottam, sorry. And the Vue and React question came from Paco Ulbrich. And and then there's a question, and the tooltip question came from Michael Eichen, or Michael Eichen. Peter Jesus asks, are there some good practices, interesting annotations for combining D3GS with Python in a Flask service, for example?
Good question. I'm using Flask and Django a lot, but they're not, I mean, it's relatively independent because you kind of do have JavaScript and D3 in the front end. And I use Flask as an API. So instead of, for example, here at the beginning, I load D3 JSON and say data simpsons.json. And in all my projects, when I use kind of these Python backends, I basically just need to replace this. Maybe it's a bit more complicated, but for the data loading to interact with the backend, I can basically use the D3 JSON to load data from the server instead of just from a static file. I will maybe post some links if I think I have some tutorials for Flask and D3.
All right.
And I also want to quickly share this. So I mentioned before Svelte. If you haven't heard it, this is kind of an alternative to React, also relatively popular in our framework that can be used in D3. And I saw some really nice projects already.
Thank you. And another question by MethMad. What are the best practices for interactivity? For example, linked elements that respond to hover or click. How do you get the specific related elements with HTML IDs? Question.
Yeah, that basically works similar to the tooltip here. I have a visual element. It's called. So here I join a rectangle and then I define a few attributes. Some are static, some have some are dynamic, and then I can just apply different different listeners with on mouse over, mouse move, etc. You could use other libraries to take care of these listeners, jQuery, for example, etc. But if we use already D3, we can use D3 for it. Yeah, so here this is just a tooltip, and I don't kind of create linked interactions between multiple views. I have here D3 examples, for example, where yeah, I have link charts basic and a dispatcher that you can check out. I will link to this website where I explain a bit more in detail how to kind of link multiple views together and create a bit more complex interactions instead of just simple tooltips. For example, if you want to click on one bar chart and then update the scalar plot.
Vancouver Trails, very interesting.
Yes, it's super insightful visualization.
Thank you very much, Michi. Much appreciated. We've run over our time. We took over the break as well,
Oh, no.
if I'm not mistaken. But that's okay. We got to see some additional juiciness. No, actually, we're sorry. I'm 15 minutes
On
off.
time.
We're used to time exactly. And now there's a break of 15 minutes. But first of all, thank you so much for a very lovely talk, as always. Usually we have a, on the Discord channel, we also have a hiring tab where lots of people are posting the open positions that they have. However, I think you're getting close to being done with your PhD, and so you might actually be looking for a job.
I will check out the hiring channel. Yes.
Just, yeah.
Thank you.
Have a look, and for everybody else, also, you know, if you have a job for Michi, let him know. Thank you so much.
Thanks.